There, I can let more people in. All right. I wanted to just let everyone know I did turn on your quiz 2A. It was hidden, and I know it was listed on your schedule, and some people were worried that they were going to be late. I had it hidden because I wanted to review it, and I did take one question out. So I should have had it back up sooner, but it's there now, so you can do it whenever you have a chance. It is turned on now. All right, so we were in this graphing section, so we're going to continue through this section. There are a few questions I'm going to point out that they're a little bit more difficult than normal. I think they were really some 1105 questions, a couple in here. I will make sure they are not on your test, okay? But you can see how to do them. This question right here is a tricky question. We looked at a domain and range of a graph before, and this one is asking domain, so it wants to know how is it acting going across, and they're going to use, this would be a set builder type notation, not complete, but part of that. And so your domain is between 16 is the leftmost point, and it's included, and 7. No, Mrs. H has that wrong. He erased that. I should not be looking at the up and down. That's the range, right? Domain is across. So this is 0, and you are touching. And this is 7, and you are touching. So you have two answer choices that you have to just look at here carefully. And this is, F is this axis, so they've labeled them differently than the X and Y. But the vertical axis will always have to do with range, and the horizontal axis will always have to do with domain. So D is what you want because we're looking at domain. So in your choices, you are going to need to pick this one. Even though they both have the 0 and the 7, the other one has the F in here. And we'll just submit that to make sure it's okay that we did what they wanted. Okay. So I thought that one was a little tricky. And I am going to skip on some of these. I'm going to skip 14 because we did several of those. 15 I'm going to do, even though it's the same type of question, but it has, it asks for set builder notation, which we, I did not have that in your other videos, so I want to make sure that you see it and can do their homework. I am going to need to make this a little bit bigger. Cut my space a little bit. All right, so we're going to write the domain and range in interval notation. All right, so we've done that a little bit already. So this is 15. We didn't do anything with 13. Well, we did the problem, but I didn't write anything down. All right, so domain. It's going to start at -3. It's not including that. So our interval notation would be -3 to 4 for domain. And you are touching the 4. That is interval notation. All right, and to put that in set builder notation, so that's the other form that they want, it's going to be the set of all x such that and then you put your rule that would be for this, and it is going to be x is between -3 and 4. So you're going to write your -3, but you're not touching it, so you're just going to use this symbol with no equals underneath. Your x goes here, and then this one you are touching, so that would be the 4. Right, so that should be our first answer, and we'll just look. -3 and 4. Right, notice on the next one, see if I can get a little more space and not mess it up. All right, I'll have to use the keyboard. All right, so they have already entered some of that notation. So you do not need to enter the symbols for a solution set or the x or the such that. You just need to enter this rule part. And maybe we should enter that so that you can see it done. Sometimes that is the issue. All right, so I'm going to do a -3 from my keyboard. So I want the inequality template, so I'll choose it. And I want just less than, and then I'll do x from my keyboard. And then I want the less than or equal to 4. And it is going to close. So it should be good there. We'll look and see if I have the same thing. Whoops. I don't want that. I want, oh, here's the answer key. Yes, that looks like mine, except they're given the whole thing there. You didn't type all that. It would mark you wrong if you type all that. Okay. So someone could not hear. How about you other guys? Anybody, can you hear me?
Yes.
Okay. So for whoever could not hear, if you will go out and back in, that will usually fix it. Okay. All right. So then they want us to do the range the same way. So really it was this other notation was what I wanted you to see there. So your range is lowest to highest. Right, your lowest point is going to be 0, and this one is on the 0, and it is not touching. So we are going to do from 0, and 1 is the highest, and we are touching. Right. When you write your range, you're going to write it the same way, but you're going to write y here. It's such that, and they will probably have that already there. 0 is less than y, which is less than or equal to 1. And sorry, I'm so close to the edge sometimes it gets weird stuff there. All right, let's see. This one we can just check. You guys have looked at me. Type that in. And this one, if we try to type it in, notice it already has the y, so it's giving you a hint. Y such that, so you're just going to type the rest of the rule. And we are going to want the inequality button or template. So 0, we want less than y, less than or equal to 1. All right, and I am going to check it. It's going to mark me half wrong because I didn't answer those other two on the template. Right, so just a little bit of notation we had not looked at yet. And there's nothing wrong with looking at it now. It just, I didn't have it in your note packet. All right, I'm going to go to 17 next. You have looked at several of these already. And this one we really have looked at too. I just picked out a couple of them. I think I can go back to a regular screen here now. All right, so this one wants domain and range from the picture. And just remember, domain is how the graph looks going to the left. And it is going forever to the left. So that is going to be negative infinity. And how does it look going to the right? So this one is going to go forever to the right as it goes up. So this would be to positive infinity, and those infinities always get parentheses. This one is limited on the range because it has the lowest point. Right, so our lowest point is going to be -1. It's your height there. You are touching it, and it goes forever up. So, no big deal there. This one, the picture just looks a little funny. It's still the same kind of question, domain and range. Right, and it does end at this point. It goes forever out here. So a domain would be going left to right. So your first point is 3, and then it goes forever to the right. You are touching the 3. And then forever to the right would be infinity. And then your range, right, lowest to highest. All right, your lowest point, because you're looking from here up. This one is going to be the highest point. This end will go down forever as it goes to the right. So you are actually going to start from negative infinity, and you are going to stop at 3. And you are touching that one. So just a little tricky there on the range. I'm going to skip those. I'm going to go down to, there's several of those domain and range ones. I am going to go to this one. And hopefully I can see enough of that. And I blew it up because it's going to be too hard to find some of those points with it being so small. All right, and this is 23A. So, and I blew it up with the little corner. Click on that and it blows it up. All right, so they want me to find Q of 4. What you're plugging in is X. All right, so Q of 4 says X equals 4. What is Y on the graph? That's what this question is saying to you. So at X equals 4, and hopefully you can see my style is showing up there. At X equals 4, you go there and then you go down to the picture or up to the picture. This time it's down. And this will be -3 will be the Y there. So I'm at 4 and I go down. -3 is the Y. So this will equal -3. Right, the next one, Q of 0. So X is 0. What is Y? So X is 0 is here. Just go up to your picture, and it is 3. Right, and the next one was the one that bothered me a little bit. Because you're going to have to look at a fraction, and it's already a little tight. They're giving, this is a backwards question though. They are giving you the Y. Q of X equals 9/2, and there is a little hint there because it gives you X in the box. So this is Y. What is x. Graphing is a place where mixed numbers or decimals are easier than an improper fraction. So I would divide that out, and you can do it just on a calculator. 9 divided by 2, you could do it by hand. It's 4.5 or 4.5. So 4.5, we're going to use that. Okay, so the y is at 4.5. All right, so when y is 4.5, so right about here, what is the x value? So at 4.5, you have to go over to the picture there, and I would say it is -1. Right, so you're looking at 4.5 because that is what they're giving you, and it's y. Go over to the graph, so you're going across this time, and -1 looks to me like it's lining up with that. And we'll put that answer in and see. We'll close this. That's the one that was worrying me for being able to see. And, oh, we can just check. It is -1. These others we can check. There we go, good. All right, let's see if that other one. All right, this one they're also giving you y. So they said it's 9. All right, so when y is 9, you're looking up through here, what is x? Right, so you find the 9 on there, and then you go over to the graph. Whoops, I'm not at 9. And -1, 2, 3, -4. So we're good there. So you just have to look carefully, and you have to say those over to yourself of what it's asking you. You guys stop me if you have any question as we go. All right, that was 23. So then I went to, I went ahead and went to 25. Those are the same kind of questions, but 25 have some that are harder, and they're going to use some skills that you haven't seen yet in this course. I think you'll probably be okay with them, but they come up in the in a couple more sections. All right, so we have a function, f of x equals 4x squared plus 4x minus 3, and they want us to evaluate. Evaluate means you're going to plug in, and so you're going to plug into every x, and parentheses are your friend when you plug in, especially with this exponent, and here to show your multiplication is a good idea. So we're going to plug in first 0. So 4 times 0 squared plus 4 times 0 minus 3. And then you work it out with order of operations. The exponent has to go first. 0 squared is 0, and then it's going to be times 4. Right? And then we'll go across. The multiplications have to be done before you add or subtract. So this is 0 plus 0 minus 3. This one gives us -3. So you've been doing those for a while. I'm going to skip the f of 2, but I'm going to do f of -2. Right? And you have to be real careful plugging in a negative if there's an exponent. You want it to go to the power. So I'm going to plug back into that original. So I have 4 and negative 2 is going to the power plus 4. And then here I'm going to go times negative 2 minus 3. So you're just substituting, but keep everything else. You do have to watch order on this one. The negative is going to go to the power. So this is negative 2 times negative 2, which is a 4. And then you're able to go across. Your multiplications go before add or subtract. So this is a 16 minus 8 minus 3, which is 8 minus 3. We should get a 5. Good. Right. These last two are the ones that are just a little bit more advanced. And they're having you evaluate this expression. So you have to plug this whole thing in to every x. So 25. And I'm going to rewrite our function. Right, and we're going to do f of x plus 1. So the whole thing goes into each x. So 4, and we need parentheses, x plus 1, squared plus 4, parentheses, x plus 1, and then your minus 3. Right. Once you have it plugged in, then you're going to follow order of operations. You do have to watch out here with your simplifying. This is a binomial squared, which we haven't talked about that yet, but you probably have learned about binomials before. But what we're going to have to do is write that twice and do FOIL, and we have to work that one out first. So we have x plus 1 times x plus 1, and FOIL is multiplying your first terms, so we're going to have x squared outside plus x inside plus x and last. All right, so I have x squared plus, this is 1x plus 1x is 2x plus 1. All right, I finished the exponent. I still have the 4 outside here. So I'm going to have to multiply that. I'm going to bring the rest down just to make it look nice. All right, so now I have to distribute this 4. So we have 4x squared plus 8x plus 4. Parentheses comes off. This one distribute. You have 4x plus 4. And then last we have a minus 3. Then you'll put like terms together. So 4x squared, there's no other x squared. 8x and 4x is 12x. And 4 plus 4 is 8. Minus 3 is a plus 5. And we'll check that. Hopefully I have it right. Okay. I'm also going to do the f of negative x. It will be a similar thing. You will put negative x in the two places where you have an x. All right, and I'm going to rewrite my original since I don't have it here. So f of negative x is 4. Put your negative x here. Squared plus 4 times negative x minus 3. So first thing you have to do is exponents. Negative x squared is negative x times negative x, which will give you a positive x squared. All right, and there's not really any math to do there. this multiplication, we can just clean it up. It's going to be a minus 4x and a minus 3. So there is nothing else to do. It was just a matter of being careful learning to plug that in. All right, make sure we're right. 4x squared minus 4x minus 3. So when they give you these variable expressions to plug in, you have to plug the whole thing every place you have a variable and use parentheses. All right, that was 25. We'll do just one piece off of 26. It is the same kind of question. So f of x is equal to 3 times the absolute value of x minus 5. So let's plug in the x plus 1. That will go instead of x. Everything else stays there. And then you'll just clean up inside. You're still going to have your absolutes. The constants go together. 1 minus 5 is a negative 4. That is actually all you can do to it. So the one I did where you had to square a binomial was more difficult than this one. Even if I had put the x squared plus 2, it would not matter because they're not going to be like terms. It would just stay there. Let's check and make sure I have the right answer before we leave that. Okay, what did Mrs. H do wrong? 3 times the absolute value of x minus 5. I put in x plus 1. You can't multiply your 3 times the into the absolute value. That is not correct. What they're saying for the answer. Let me make a note about that. We'll enter this answer because you don't know what x is. You don't know what it is. You can't distribute that 3 into an absolute value. So this is 26 and f of x plus 1. Their answer is minus 12. All right, I'm going to try to enter what I think is the correct answer. So 3, I need the absolute value symbols, which is here on your template. It should be n inside x minus 4. And then you're done with it. Right, I'm going to just submit it, and it marked what I put in right. Their answer key was wrong. Okay, this is what you would need, because you're not allowed to distribute them. All right, we'll let that one go there. Right, 27. We did a few of these on that other graph that was a little hard to see. All right, and they want us to find g of negative 1. So this is saying when x is negative 1, what is y on the graph? When you get used to these are not hard at all, right? So x is negative 1 is here, and you just go up to the graph, and it is going to be 2. So, good there. 28, I did that one too. Kind of the same kind. Right, they say f of 1, evaluate f of 1, looking at the graph, so it's the same kind of question. X is 1, what is y? Here is your 1, go up to the picture, so it's going to be 2. Right, and this says solve. Right, this time they're giving us f of x equals 1, so they're telling us y equals 1. So part 2 of that, f of x, which is the same as y, equals 1. So what is the x? So just a backwards question. Anytime you get confused, replace f of x with y. And so when my y is 1, what is the x? So x is going to be negative 2. So we go up to the y of 1 and negative 2. And check that. Okay. All right. These, it's just learning to understand what a function means and take it out of that word problem, and you're just writing a function for it. So you're not really doing math. Says the amount of garbage G in tons per week produced by a city of population P measured in thousands of people is given by this formula. So G equals F of P. And G is the amount of garbage. Right, so we have the town of Tola has a population of 30 in thousands, so 30,000, and produces 10 tons of garbage each week. Express this in terms of the function f. So the garbage is 10 tons, and this is of the population. So your population is 30, and they're using thousands in there. So f of 30 equals 10. Your order doesn't really matter there. And you would use parentheses to type that notation in. Right, one more of those. All right, so this one says we have a $175 gift card for gas. You spend on average $25 per week for gas. Write a function to model this situation where W is the number of weeks and G of W is the value in dollars remaining on the card. All right, so we have G of W. Right, we start out with $175, and then we're going to subtract off 25 for every week, and they said to use W as the number of weeks. So that should be our function. Let's check. Good. And now we want to evaluate. So this means after 3 weeks, how much money should she have left on the card? But you're just going to plug in the 3 into this function. So 175 minus 25 times 3, this would be 75. So she should have $100 left. Good. All right, that is 30, and I'm going to skip 31 because it's very similar to those others we did, and it doesn't even have x's to plug in. This one is just a nice summary question of things about the graph. So we have done all of these skills already. It's just going to summarize with us. All right, so we have this picture and we want to answer these things about it. So first of all, domain, and I'm going to have to make that bigger to see it. So domain, range, and x-intercept, so I can get that far. All right, so domain. All right, your leftmost point, -7, and it's a solid circle, so -7. The rightmost point is 5, and it is a solid circle, so a bracket. All right, that's domain. Range was next. All right, lowest point, so -7, and you're touching it. And highest point is 5, and you are also touching it. So our domain and our range were actually the same. All right, next it asks about x-intercept. So the point where the graph crosses the x-axis is right here. It is -2. If they ask for an ordered pair, the answer is -2, 0. So your opposite piece is 0 of what they ask for. All right, I'm going to guess that it's asking y-intercept. And y-intercept would be where it crosses the y-axis, which is down here at -2. It is also -2. It's a different point than the other one, but it's the same thing. Right, and if they ask for an ordered pair, it will be 0, -2. All right, let's see if I'm going to have to scroll that up. All right, we might as well check these as we go. -7 to 5, -7 to 5, x-intercepts, -2. So they did not want an ordered pair. Y-intercept, -2. They want f of -5, f of -6, and is it a function? We'll do that one first. That is your vertical line test. And this one is a function. There is no place you could draw a vertical line that would hit more than once, so this is a yes. All right, f of -5. So when x is -5, what is y? And that would be 3. F of -6 would be 4. So that one just kind of reviewed a whole bunch of things about graphs. So this one is 3, this one is 4, and this one is a function. It's going to mark me wrong for everything but that one little tiny bit. Oh, that was the key to that one. Okay, so I didn't hit submit. Submit's down here. All right, we don't need to submit. And that is the last problem in that section. So that was kind of a leftover section. So give me a minute, and I'm going to switch into the one for today. And you are going back to more, this one is definitely algebra. It is not graphing. And it is going to be your exponent rules. Here is that, no, you'd already done that quiz. Here is that other quiz I turned on. Okay. Okay, so we are here. And this one, a lot of these problems have, let's see what this is, Mod 2, Homework 5. So these are exponent rules and then scientific notation at the bottom. A lot of these first ones have the rules. They're kind of a teaching thing, which you should have reviewed already. And this is like base is multiplied, keep the base and add. And they just want you to do these, keep the base and add. This one, what they're saying here is you have to type parentheses because these are variables up here. So when you do, I put the W in, I need the exponent button. All right, and I have to put P plus R. It's going to be P plus R. Keep the base, add the exponents. But if I just put the P beside that, it would think that's the only piece that goes there. So I need the parentheses, and I just did that from my keyboard, P plus R, and close the parentheses, and then that's all going to that base. Right? These you just add the numbers. This is going to be V to the 20th. This one, you still can do it that way. Keep the base, which is 3, add the exponents, which is 7. So 3 to the 7th would be that one. Right? And it would not accept it if you type that in. I showed that as the key, but it wouldn't take it. You would have to type it with the parentheses. But they give you a little clue there. Right. We might look at this one piece here. So this is on problem 1. We're just kind of picking this apart. This one does not fit with any of your exponent rules, so you have to be careful because this is a plus. It is not times. So the exponent rules don't work. If it was times, they would. What you have to do is just work them out. So this gives you 4 plus 2 to the 5th is a 32, and that would give you 36. So it is not one that you can do a shortcut like the one above. This was multiplication. So that is the difference there. And this one is exploring some, that next rule. Use my mouse. Right, I don't think those will be very hard for you. So I'm going to go to problem 8. Right, and this one wants us to simplify this product to a power. It just has a place you have to be careful. It is not that hard either. The 4 is going down to each one. And so you're going to have -3 to the 4th power. Right, that's a plain number. It is not going to multiply. This one, it will multiply. But if you write this step, you'll be good. So -3 to the 4th, you're going to work out on your calculator. And when you put it in your calculator, you want parentheses. The negative was inside the parentheses originally, so it needs to be here. It's going to give you positive because you're going to end up with 4 negatives. So I have to put it in parentheses for it to evaluate correctly. And it gives me a positive 81. For the variable, I will keep the base and multiply. So 12 times 4, I believe, is 48. So 81V to the 48. All right. I skipped 9. You're just going to rearrange that one, do your numbers, then do your Z's. 10 is a big deal. And it's just whether or not a negative gets to go to a power. So knowing the difference between these two expressions. And the second one is easier. If you're in parentheses, whatever is in here is what goes. So this means -4 times -4, which gives you a positive 16. It's only the piece right beside the exponent that gets to go. So 4 gets to go, not the sign unless there's parentheses. So this means do 4 times 4, and when you're all done, you have one sign. So this one gives you a -16. So this is just something to be careful about. So whether your negative gets to go to the power or not. All right, then I skip to 13. This one is just a little more complicated than some. So we have 2a to the negative 4b cubed. All of this is to the negative 1. And 2ab to the negative 4c to the 0. We need to deal with that parentheses first. And there is more than one way to do these problems. So I could take the exponent down to each one. What I'm going to do instead, I think, is I'm going to shift that whole parentheses to the denominator for this outside exponent. So two different approaches there, right? And that will change the exponent to a positive 1, which is not going to change anything. So when I do that, there will be nothing left in the numerator. This is going to move down. This whole thing will move down. It will leave me a 1 up there. This is what I already had down there. Right, and I'm moving this all down. Now it's going to be multiplied. But since now it will be a positive 1, so I've shifted it down, it becomes a positive 1, I can remove that because anything to the first power gives you back the same thing. So I can take that off, and hopefully I won't erase the rest here. I'm going to get that parentheses off. All right, and now I have to just clean up the denominator. This c to the 0 is going to be 1. That's one of your definitions. So because it's multiplied by something else, we're not going to need it at all. Right, I'm just going to regroup a little bit. My numbers are going to multiply. 2 times 2 is 4. All right, for my a's, you can work with them right here, or you could shift this one up top. It doesn't matter. You'll get the same answer at the end. So they're side by side here. The rule would be keep the base and add. So you have 1 and a negative 4. It's going to give us a to the negative 3. We'll leave it for now, but it will have to move to the top then. Right, let's see about the b's. So I have a negative 4 and 3. They are straight across. So the rule is keep the base and add. You still have to watch the sign rules. Negative 4 plus 3 will give us a negative 1. Right, and we took care of anything to the 0 is 1. So we didn't need that since something else is there. The only thing you have left to do is these pieces with the negative exponents have to shift. They're going to go to the top, and they are going to get positive exponents. Since you'll have something else there, you won't need the 1 anymore. So you're going to have a cubed b to the first over 4. And you don't have to write that 1 on the b. You could, but you don't have to. Right? And you could have started a different way on that problem if you wanted. Any questions there? All right. I did pick 14. This one's an easier one than the other one. All right, so we have a parentheses negative 2z to the 4th over 3. And the whole thing is to the 3rd power. Your rule is a fraction to a power. It goes with the numerator and denominator. So it's just going to make 2 small problems. And then this will be a product to a power, so it's going to go down to each one. I'm going to go down to have enough room. So I will have negative 2 to the 3rd, z to the 4th to the 3rd, and I'll work those out. 3 to the third will be a calculator problem. Should be 27. Right, and negative 2 to the third is going to give me a negative 8. This one, keep the base and multiply over your 27. Good. And if you had put the 3 directly on each one, that would have worked the same. Right. I'm going to skip that one. I'm going to come back to that 16 through 18 if I have time at the end. They're complicated. Right, I marked 22, so let's go there. Right. The main thing on this one is, and it doesn't really matter, but I would tend to go ahead and use that first rule of a product to a power rather than dealing with the negatives, right? So a product to a power takes that down to each one, a to the negative 2 to the negative 5, b to the 4th to the negative 5, and you're going to keep the base and multiply. That turns this one into a positive. The b is still a negative, and so now the b is going to have to shift. The a is good. The b is going to have to shift. Ah, Mrs. H. Oh, wow. Sorry, guys. What do you do with these exponents? Power to a power, keep the base and multiply. That's a strike. All right. Good thing we have an eraser. And this would be positive 20. Any question there? All right. I want to get these scientific notation ones for you guys, the ones with arithmetic. You've probably done scientific notation before, where you have to have one digit to the left of the decimal, and then it's times 10 to any power. You will keep these on the same line, but I wanted to do a couple of these with arithmetic because you have to do some work to get the answer back to scientific notation. I'm going to do 28 and then I'll come back to 26. So these are two numbers that are in scientific notation. And so you're going to do this arithmetic. You're going to multiply two numbers that are in scientific notation. And you use scientific notation. It's really used by scientists for very tiny numbers or very large numbers, so they can do the math without the zeros. And so on this problem, what you want to notice is this is all multiplication. You've got multiplication here, here, and in between these. When you have all multiplication, you are allowed to rearrange it. That is called the associative law of multiplication. So I'm going to pull these plain numbers and put them together. And then I'm going to put my powers of 10. I'll just put a dot here. So I have 10 to the negative 7, and I have 10 to the negative 1. All right, so this will be a plain old multiplication. I'll go to my calculator. 3.6 times 7.2, enter. So I have 25.92, and I don't know about this software. The other software I've used, you use plain old X here. X is used. in scientific notation, even though we don't use it in most other places. All right, for your power of 10, we're going to do it with the exponent rule. And you don't want to do any shifting. You want everything on one line for scientific notation. So this is like bases multiplied. The rule is keep the base and add. You'll still have to follow sign rules, but they're like signs. So they're going to add and keep the sign. All right, we have done all the math that was there. The problem with this is it's no longer scientific notation. So you have to know how to put this piece back in scientific notation. The trouble is this decimal is wrong. It needs the decimal to be over here with only one digit left on the left of the decimal. So we need to move that decimal that way. Now you can't just move it because you want to. You have to compensate for that. So if this one goes to the left, this one needs to go the other way. So I'm going to have 2.592 times 10, right? Now be careful here. Think of your number line. You're at -8, but you want to go to the other side, which would be -7. That is what would be bigger. This went to the left, so made it smaller. This one goes to the right, but your number line, your -8 is here and your -7 is here. So don't get confused by that. Make your number line if you need it. All right. And we can enter that and see what they might fuss about. Make sure I'm doing the right problem. 2.592. And I'm going to use a plain old X from the keyboard. Yeah, it looks like it's not happy with me. 10 to the -7. All right, it's going to say no. All right, so I'm going to go back in this answer and I will change that to a multiplication. Now, they're not giving me a multiplication symbol on here. From your keyboard, it's like the asterisk key. So that star, that is what they use for multiplication. So let's put that in, and it did put a dot, so that should be good. So on the keyboard, I did the one that is an asterisk if you have a number pad, or it is above the 8. And it probably says that on some of these. And it turned it into a times here. So let's submit and see if they're happy with that. Okay, so they're happy with that way. So use the asterisk thing. All right, let me go back to that other scientific notation, 126. Right, so this one you are dividing these. Right, and I'm going to kind of think categories here. So I'm going to do numbers, and then I'm going to do my powers of 10. And for the numbers I need to divide, so I'm going to go in my calculator. So I have 2.88 divided by 3.6 equals 0.8. Right, and these I'm going to subtract top to bottom. So 10 minus 16 minus 6 gives me 10. Right, now the trouble is this is not in scientific notation anymore. Your decimal is in the wrong place. You have to have one non-zero digit on the left of the decimal. So you need your decimal to move to the right. If this one moves to the right, this one has to move the other way. So it will have to move left to make up for this. So I should have, with my new answer, 8, and you don't have to put the decimal at the end there, times 10, and this one is going to go down. Right, so I'll use the keyboard 8, and then that star, which is above the 8, it did put a dot. My 10, my exponent button, and 9. All right, and then they want me to express it in decimal notation. Just to convert from here to decimal notation, you have to apply the multiplication. This exponent is going to move your decimal to the right 9 places. So right now we are here. We're going to need 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the decimals at the end. I'm going to put these commas to help me see them, but you don't type them in. All right, and I'll type that. So I have 8, and then we'll just count 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, and we'll submit. So they were happy with that. Okay. All right. That's the 2 kinds of things there at the end. I said I would go back to 16 through 18 if we had time. We might have time for one of them. They're pretty long. And it looks like there's a video there for help. If you can't do those, I will make a little video and add it also. All right, so we can probably get 16 done. So we have u to the 6th, z squared to the 3rd, a negative u to the 5th, z cubed to the 4th over negative u z to the 6th, u to the 6th squared. Whew. All right, and I am going to move this and get me a little bit more space here. Okay, so we want these parentheses to come off first. And so this one, if we take it down, you can write these, but it's only variables in there. If there's a number in there, you have to watch out because it will raise to the power. So they're going to multiply. It's going to be power to a power. So since there's so many, we won't write each one. It's u to the 6th to the 3rd, and then z squared to the 3rd. But then this will multiply. So this is going to give me u to the 18 and z to the 6th. And that parentheses comes off. All right, and we are on the numerator. Okay, this is like a negative 1 in here. And this one I'm going to do, the negative 1 to the 4th power is 4 copies of negative 1, which will give you positive 1. So it's going to be positive 1 here, which we won't have to write at all. So we can leave it out. But that was taking the 4 to that power. It actually raises to the power, a number does. For your variables, the exponents are going to multiply. So I'm going to have u to the 20th, z to the 12th. All right? And let's just put those together on that numerator. Right, now they're straight across, so your exponents are going to add. So for my u's, I should get 38. For my z's, I should get 18. All right, denominator. This is a -1 in front. -1 squared is going to be like this one because it's an even exponent, you're going to get negative. It's an even exponent, so you're going to get positive. Wow, Mrs. H. All right, so it's just a 1, so you don't have to write it. For the variables, we'll just go ahead and take it down. So it's going to be a u squared. It will be z to the 12th. And it will be u to the 12th. 6 times 2 would be 12. All right, I already cleaned that numerator up. And so for the denominator, these u's can go together. This would give me, they're straight across, so they're going to keep the base and add. So this is going to be u to the 14 and z to the 12th here. All right, now parentheses are all gone. This kind of problem, I like to think of these as, I think categories. I'm going to think u's and z's, right? And so it's easy from here. When you have that fraction, you're going to keep the base and subtract. So for the u's, we're going to keep the u. We're going to subtract 38 minus 14. So that is going to leave me 24, right? And then the z's. So 18 minus 12 will leave me 6. So a lot of work there. I hope I have the right answer. Good. Okay. All right. 17 or 18. Let's do 18. That one I can probably finish. I don't think I could finish 17. All right. So 18. One thing I like to do, if there's anything inside that's alike or can be cleaned up, I would go ahead and do that. And you can do your y's. All right, they're going to subtract, it's going to leave you just a y. So we have 6y to the first over a cubed. This is to the -2. There are two different ways you can go from right here. You can just take this with the numerator and denominator, or you could flip this fraction and this becomes positive. So whichever one clicks for you. I'm going to just take it with the top and the bottom. That way you're using the regular rule. Nothing extra to remember. Okay, this -2 is going down to each one. You have to be a little careful there with a number to a negative power. You cannot work that one out until it is moved. You know, and if I had been really clever and I saw negative on the both of those, they're going to switch places. All right, and this will give me a to the -6. All of these are going to switch places because they have negative exponents. So we're going to do 6. Down here it gets a positive. Y, it gets a +2. And the a will go up. 6 squared you should work out. So we'll go back this way a little bit. A to the 6 over 36y squared. So that one wasn't too bad. Right. Okay, I am going to stop there. And if you get stuck on that other one, I don't mind to work it later and throw up a video. I have another class, so I can't do it right now. But you guys have a great day. Thanks for coming.